Now I told you underdamped system is very, very important. Just a small discussion on this graph and then we will close the class. This is the underdamped system. This is the underdamped system. Okay, second order system graph. C of t graph of underdamped second order system. Underdamped second order system. You can see the graph is slowly increasing, going above the dotted line. One is the input. No, this is the input 1. This is the input 1. A thick line is drawn. Okay, this line is input. You should be very clear what is there in the picture. And this graph is output. This graph is output. This is a continuous graph. Output is a continuous graph. You can see above the horizontal line, then coming down, going up, coming down, like that. Okay. And here, there is some name for the upper side and down side. And the next class I will tell you. Here, the maximum point for the first time, this is the maximum height it is reaching for the first time. Okay. And the time taken for that is called peak time. TP means this is the peak time. Time taken to reach the maximum height for the first time. Time taken to reach the maximum height for the first time. That is called peak time. Okay. So 50% of that height is called delay time. 50% of that height means here you can see 50%. 0.5 means 50% of the, this is the input value. This is the 100%. Okay. This point is nothing but 100%. So 50% means half of that. The time taken to reach 50% is called delay time. Time taken to reach 50% is called delay time. I am writing TD here. TD here. Delay time means 50%. Okay. And reaching 100% means reaching the input. For the first time, it is touching the input here. For the second time, it is touching the input here. Okay. For the third time, it is touching the input here. Fourth time, like that, any number of times we cannot predict. Finally, after some time, it will settle down very close to the input. That we know. It will settle down very close to the input. Okay. So what we have seen, the maximum height it reached, the time taken is called peak time. And reaching 50% of the final value. Final value means this one. One is the final value. Okay. This one is the final value. You can write anywhere. This is the final value. Okay. This horizontal line is the final value. This horizontal line is the final value. Okay. That we are taking as 100%. And half of that is 50%. Time taken for that is called delay time. Time taken for that is called delay time. Now we have one more thing. Here you can see 0.98. 0.98. Okay. We are having some vertical dotted line here. And it is written TR here. TR means rise time. TR means rise time. First one is delay time. Second one is rise time. We are having number of definitions for rise time. 0 to 100%, 10 to 90%, 5% to 95%. We have 3 definitions for rise time. Okay, in the next class we will see that. And delay time is written at the bottom. I didn't see, so I have written over here. Okay, TD delay time. It is unnecessarily I have written. No problem. This is delay time. And reaching the final steady state value happening over here. TS means settling time. Settling time means it is settling down to of that value. This is 100%. 1 means 100% we are taking. 50% of that. 50% of that means 0.5. Okay, reaching first time 1 means we are taking 100% and the time is rise time. And reaching half of that 50% means the time is called delay time. TD, delay time. And then when it is going to the maximum height, after that the height goes on decreasing. Maximum it will not increase. Maximum it will not increase. After only the first time it will go to the maximum height. After that the sinusoidal oscillations height will keep on decreasing because intention is to stay back at the constant value 1. Okay, constant value 1. 1 is the input. Step input means 1. So the maximum height reached for the in the beginning, maximum height reached. The time taken is called peak time. Time taken is called peak time. And how much time it is taking to settle down with this final value. To settle down with this final value. For example, if we take the grades, O grade means 95 and above is considered as O grade. It is not 100 out of 100 is only O grade, isn't it? So in that case, we are also giving some tolerance. We are also giving some tolerance, 2% or 5%. So this is the constant horizontal line. This is the constant horizontal line. 100% we are telling this as the line. Whether it is 105 or 95, whether it is 102 or 98, 2% or 5%, 3%, something is allowed. Okay, tolerance is allowed. All these are considered to be reaching the final steady state. It has reached the final steady state because this is 1 or 2, 2% above the final value, then 2% below the final value, and later on it decreases. Exactly, it will not come to 1, however, 99% or 101, okay, it is considered as the final value. The time taking for that is called settling time. Settling time means the output is reaching the final steady state value with a tolerance of 2 to 5%. With a tolerance of 2 to 5%, we are taking it, it has reached the final value. Okay, so we have seen 4 things: rise time, peak time, delay time, and settling time. The fifth one is peak overshoot. So peak overshoot, MP. MP means peak overshoot. So it is the maximum height to the final steady state value. Difference between it is the ratio of numerator maximum value to the final value divided by final value. So that is the peak overshoot. So if you see the equations regarding this is the delay time. Equation is 1 plus 0.7 eta by omega n. Eta is damping ratio, omega n is natural frequency. 1 plus 0.7 eta by omega n is the equation for delay time. Delay time is 50% of the final value. Okay, time taken to reach 50% of the final value. Time taken to reach 50% of the final value. Final value is 1. Okay, 50% means 0.5. So the equation for this TD, delay time, equation for this TD is 1 plus 0.7 eta by omega n. Units will be seconds because this is time. Next, rise time. Rise time, we will take it as, instead of beta, I can also take this as alpha. Instead of beta, I can also take it as alpha. So here the equation, I can write it as, this is equal to pi minus theta divided by omega d. Pi minus theta divided by omega d. So theta or beta, any representation you use. And in why I am using theta, in most of the textbooks we will be finding theta, so it will be easy for us if we take theta. So pi minus theta by omega d. Theta is tan inverse square root of 1 minus eta square by eta. Square root of 1 minus eta square by eta. That is the theta value. And if you see omega d, this is damped frequency. Omega n means natural frequency. Omega d is omega n into square root of 1 minus eta square, damped frequency. So rise time means we had definition 10% to 90% of the final steady state value. In the graph, I didn't explain that. Yes, here, first time when it is reaching the 1, okay, it is called rise time. We have seen that first time when the output graph reaches 1, the time taken, we are calling it as rise time. Means it is 0 to 100%. Okay, 50% means delay time, 0 to 100%, that is rise time. Okay, that is particularly in the case of underdamped system. The time taken 0 to 100% of the final value, okay, output graph is reaching, that is called underdamped system. For overdamped system, the same can be considered 10% to 90%. Critically damped system, we can take time taken from 5% to 95%. Okay, there are 3 definitions for rise time. 0 to 100% in the case of underdamped system, 10 to 90% in the case of overdamped system. This is mostly valid. 10% to 90%, this formula in all other subjects. Okay, rise time means 10 to 90% only you will study. In other subjects also. Okay, in other subjects also, this is the main formula, 10% to 90%. Okay, but if it is underdamped system, you can take 0 to 100%. If it is critically damped system, you can say 5 to 95%. 5 to 95%. This is in critically damped system. But the standard definition is 10 to 90% only. Standard definition. In other subjects also, whenever you come across rise time, this is the standard definition. Time taken for the output to reach from 10% to 90% of the final steady state value. Okay, this is the equation for finding rise time, pi minus theta by omega d, pi minus theta by omega d. Okay, and theta equation we have, damped frequency also we have equation. Next formula, peak overshoot, peak overshoot. So I was telling you peak overshoot means, this is nothing but maximum value, okay, maximum value minus final value divided by final value, divided by final value. In other way, what we can write, this MP is nothing but, okay, C of t at the peak time minus C of infinite means final value divided by C of infinite. In textbooks, you will find like this, some equation. C of TP means C of t at TP. Okay, C of t means final graph. C of t means final graph. At TP means peak time. Okay, you see the graph. You see the graph. So this point, I'm talking about this point. Okay, the output C of t at this point can be called as C of TP because this is the peak time. Okay, output at peak time. C of TP means this maximum point, output at peak time. C of infinite means at infinity you can see what is the output graph, it is reaching 1. Okay, so C of infinite means the graph at infinite time, graph at infinite time. That infinite time is nothing but 1. Okay, which means this arrow mark is written, this arrow mark, numerator I have calculated this arrow mark, okay, which is maximum value C of TP minus C of infinite means this value 1, this value 1. So the height, this height, arrow mark, this height is the numerator, what I have written MP, peak overshoot. Divided by C of infinite means C of infinite value is 1. At infinity, it is reaching value 1 only. Output graph is reaching value 1. Okay, so divided by denominator C of infinite means value is 1. So that is what I have written here, the formula for MP. In other way, if you substitute, simplify, and there is a background derivation for this, after doing that simplification, we will finally come up with this formula for peak overshoot, e power minus eta pi by square root of 1 minus eta square into 100. E power minus eta pi by square root of 1 minus eta square into 100. This is peak overshoot. We have two more parameters, peak time. Rise time completed, pi minus theta by omega d. Peak time is pi by omega d. That theta alone will not come. Okay. Rise time is pi minus theta by omega d. That minus theta, if you remove, that is peak time, pi by omega d. Okay, peak time means the time taken. Just now we have seen the peak overshoot. Okay, so the time taken for reaching the maximum value for the first time, maximum height for the only first time it will come to the maximum height. So this is the peak time formula. And the last one is settling time. Settling time means when it is reaching the that standard final value 1 with 2 to 5% tolerance. With 2 to 5% tolerance, it is 4 time constant. Time constant is 1 by eta omega n. Time constant is 1 by eta omega n. Okay. So these are the 5 formulas we have seen. These are the 5 formulas we have seen. Okay. Just we will have a list. Delay time, we had 1 plus 0.7 eta by omega d. Then peak time, we had pi by omega d. Rise time, we had pi minus theta by omega d. And peak overshoot, we had peak overshoot e power minus eta pi divided by square root of 1 minus eta square, and into 100 means you are telling it in percentage. Without 100 means absolute value. If you are calculating peak overshoot in percentage, then into 100 also required. Okay. And the fifth one is settling time present here. This is the first one, delay time. Second one, rise time. Third one, second one, peak time. Third one, rise time. Fourth one, peak overshoot. And the fifth one is settling time, 4 time constant or 3 time constant based on the tolerance, Okay, these are the 5 time domain specifications. You can see here, all these 5 are called time domain specifications. All these 5 we are taking from underdamped system. All this 5 we are taking from second order under damped system.